We want to determine the limit if it exists. We will first determine the limit by performing algebraic techniques. Notice if we try to perform direct substitution to determine the limit, we have 5 divided by 0 minus 5 divided by 0. This does not mean the limit does not exist. We can also perform algebraic techniques to simplify a function that will remove discontinuity and allow us to find the limit by performing direct substitution. So in this case, the only thing we can possibly do here is begin by subtracting the two fractions. In order to subtract the fractions, we must have a common denominator. The least common denominator is the product of x and the square root of the quantity 1 plus x. And therefore we'll multiply the numerator and denominator of the second fraction by the square root of the quantity 1 plus x. Notice now we do have a common denominator. The common denominator again is x times the square root of the quantity 1 plus x. In the numerator we now have 5 minus 5 times the square root of the quantity 1 plus x. If we try to perform substitution now, we have the indeterminate form of 0 divided by 0. So now we will multiply the numerator and denominator by the conjugate of the numerator, which is 5 plus 5 times the square root of the quantity 1 plus x. We will leave the denominator as a product. We will have x times the square root of the quantity 1 plus x times the quantity 5 plus 5 times the square root of the quantity 1 plus x. And now let's multiply the numerator. 5 times 5 is 25. The next two products should be opposites. We have 5 times positive 5 times the square root of the quantity 1 plus x, which is 25 times the square root of the quantity 1 plus x. And the next product is negative 25 times the square root of the quantity 1 plus x, which sums to 0. And the last product is negative 5 square root of the quantity 1 plus x times positive 5 square root of the quantity 1 plus x, which is going to give us minus 5 times 5 is 25. And then square root of the quantity 1 plus x times itself is just going to give us the quantity 1 plus x. Let's go ahead and simplify the numerator. We have 25 minus 25 minus 25x, which simplifies to negative 25x. Notice now we have a common factor of x between the numerator and denominator that will simplify to 1. X divided by x simplifies to 1. By simplifying this factor of x out, we are eliminating the removable discontinuity at x equals 0. So our simplified expression is negative 25 divided by the product of the square root of the quantity 1 plus x and 5 plus 5 times the square root of the quantity 1 plus x. So going back to the original limit, this limit is equal to the limit of negative 25 divided by the product of the square root of the quantity 1 plus x and 5 plus 5 times the square root of the quantity 1 plus x as x approaches 0. And now we can evaluate this limit by performing direct substitution. We have negative 25 divided by, if x is 0, we have the square root of 1 times the quantity 5 plus 5 square root 1. Simplifying again, we have negative 25 all over, this is just 1 times 10 or 10, and negative 25 tenths simplifies to negative 5 halves, or if we want, negative 2.5. So this was quite a bit of work. Let's verify the results using a table of values as well as the graph of the original function. So looking at the table of values, notice if we approach 0 from the left, our value is less than 0. The function values do approach at negative 2.5 or negative 5 halves. And as we approach x equals 0 from values greater than 0 or from the right, again we can see the function values do approach negative 2.5 or negative 5 halves. Now looking at the graph, most graphing software is not going to show removable discontinuity. Notice how the function is undefined at x equals 0. So there is a hole here at x equals 0. But either way, notice as we approach x equals 0 from the left and from the right, we can see we are approaching the function value of negative 2.5 or negative 5 halves, which does verify our work is correct. I hope you found this helpful.